In the vast silence of space, where stars burn and galaxies swirl, something strange once crackled through the void, a radio signal so peculiar, so enigmatic, that it left scientists scratching their heads. Known as the wow signal, this brief burst of energy detected in 1977 wasn't just unusual, it was a cosmic whisper from the unknown. And it's just one of countless mysteries that remind us how much we still don't understand about the universe. From bizarre objects that shouldn't exist to signals that defy explanation, space is a treasure trove of phenomena that challenge everything we think we know. Today, we're diving into the most bizarre things found in space discoveries that stretch the limits of science and ignite our imaginations. You'll encounter cosmic oddities that seem to break the rules of physics, unexplained signals that hint at something beyond our comprehension, and phenomena so strange they leave even the brightest minds baffled. So, buckle up, this is a journey into the unknown, where every discovery raises more questions than answers, and the universe reveals just how mysterious it truly is. In the vast expanse of the cosmos, there are moments that stop us in our tracks, moments that challenge everything we think we know about the universe. One such moment occurred on August 15, 1977, when a radio telescope in Ohio picked up something extraordinary, the wow signal. For 72 seconds, a burst of radio waves so powerful and so unusual flooded the receiver, it left astronomers stunned. The signal was so intense that Jerry Amon, the scientist who first spotted it, circled the data on the printout and wrote a single word in the margin: wow. And just like that, the wow signal became one of the most tantalizing mysteries in the history of astronomy. What made this signal so remarkable? For starters, it came from the direction of the constellation Sagittarius, a region dense with stars and cosmic activity. But here's the kicker: it was a narrowband signal, meaning it was concentrated on one specific frequency, one that's often associated with hydrogen, the most abundant element in the universe. This isn't the kind of signal you'd expect from a natural cosmic event like a supernova or a pulsar. It was precise, deliberate, and utterly unique, and then, just as quickly as it appeared, it vanished. Despite decades of searching, the wow signal has never been detected again. So, what could it have been? Theories abound. Some scientists believe it could have been a message from an extraterrestrial civilization, a fleeting hello from a distant world. Others argue it might have been a natural phenomenon we don't yet understand, like a rare cosmic flare or an undiscovered type of interstellar object. But here's the thing: even after nearly 50 years, no one has been able to definitively explain it. The wow signal remains an enigma, a cosmic whisper that has sparked endless debate and fascination. Could it be proof of intelligent life out there, or is it just another reminder of how much we still have to learn about the universe? This mystery isn't just about the signal itself, it's about what it represents. It challenges us to look beyond our assumptions and consider the possibility that we're not alone. And while the wow signal stands out as one of the most compelling examples, it's far from the only unexplained phenomenon coming from the depths of space. From strange repeating signals to bizarre celestial objects, the universe is full of mysteries waiting to be unraveled. And speaking of mysteries, let's turn our attention to another cosmic oddity that has left scientists scratching their heads. Now, let's shift our gaze to one of the most perplexing cosmic phenomena ever detected: fast radio bursts, or FRB. Picture this: in just a fraction of a second, a burst of radio waves releases more energy than our sun does in months. These flashes, lasting mere milliseconds, originate from galaxies billions of light years away, and their discovery in 2007 left astronomers scratching their heads. What could possibly produce such an intense, fleeting signal from the depths of space? At first, scientists thought these bursts might be one-time events, cosmic accidents perhaps. But then, in 2016, something extraordinary happened. A repeating FRB, labeled FRB 121102, was detected. Unlike the single bursts, this one sent out signals multiple times, adding another layer of intrigue to the mystery. Why would one source repeat while others simply vanish? Theories abound, ranging from the collision of neutron stars to the explosive deaths of massive stars. Some even speculate, though cautiously, that these bursts could be evidence of advanced alien civilizations, using unimaginably powerful technology to communicate across the cosmos. But the truth is, we still don't know. Fast radio bursts are like cosmic whispers, faint and fleeting, yet packed with secrets about the universe, and they're not alone. The cosmos is full of transient events, sudden, short-lived phenomena that challenge our understanding of how the universe works. From gamma-ray bursts to mysterious flashes of light, these events remind us just how much we have yet to discover. So, as we ponder the enigma of FRBs, let's keep our eyes and minds open to the countless other cosmic riddles waiting to be unraveled. Now, let's turn our attention to one of the most baffling cosmic mysteries of recent years, Tabby Star, also known as KIC 8462852. This star, located about 1,400 light-years away in the constellation Cygnus, has been causing quite a stir in the astronomical community. Unlike most stars which dim and brighten in predictable patterns, Tabby Star behaves in a way that defies all conventional explanations. Its light doesn't just dip slightly, it plummets by up to 22% at times, a staggering amount that can't be explained by the presence of an orbiting planet or even a group of planets. So, what could possibly cause such dramatic fluctuations? One of the earliest and most tantalizing theories suggested that we might be looking at an alien megastructure, a massive construction like a Dyson sphere designed to harness the star's energy. Imagine a civilization advanced enough to build something on that scale, and you can see why this idea captured the public's imagination. But while the alien megastructure theory is exciting, scientists have been quick to point out that it's not the only possibility. Another leading explanation involves a swarm of comets or debris orbiting the star. If a large enough cluster of comets passed in front of Tabby Star, they could block a significant amount of its light, creating those bizarre dimming patterns. However, even this theory has its holes. The sheer scale of the dimming and the irregular timing of the events make it hard to fully explain with comets alone. And then there's the question of why Tabby Star's overall brightness seems to be gradually fading over time, something no comet swarm or planet could account for. This has led to even more exotic ideas, like the possibility of dust clouds or even the star consuming a planet, but none of these fully fit the data either. The truth is, despite years of observation and countless theories, Tabby Star remains an enigma. But here's the kicker, Tabby Star isn't alone. Astronomers have since discovered other stars with similarly strange behavior, each adding another layer of mystery to the cosmic puzzle. What's clear is that our universe is far stranger than we ever imagined, and the answers, when they come, might just rewrite everything we thought we knew about stars and the forces that shape them. Now, let's turn our attention to one of the most enduring enigmas of space lore, the Black Knight satellite. This mysterious object, supposedly an alien artifact orbiting Earth, has sparked countless theories and debates for decades. The story begins in the late 1950s, when amateur radio operators reportedly picked up strange signals echoing from the void. These signals were later linked to an unidentified object in polar orbit, which some claimed was an ancient alien satellite monitoring our planet. But the truth, as it often does, lies somewhere between fact and fiction. The Black Knight's origins are far more terrestrial than extraterrestrial. What many believe to be an alien relic is likely a combination of misinterpreted space debris and remnants from early satellite launches. During the Cold War, both the United States and the Soviet Union were racing to dominate space, launching countless satellites and probes. Some of these missions left behind fragments, metal panels, discarded equipment, or even defunct satellites floating aimlessly in orbit. One notable example is a thermal blanket lost during a spacewalk from the International Space Station, which eerily resembles the descriptions of the Black Knight. Yet the myth persists. Why? Perhaps it's the allure of the unknown, the idea that we're not alone in the universe. The Black Knight taps into a deep human fascination with the possibility of extraterrestrial intelligence observing us from the shadows. Conspiracy theorists have latched onto blurry images, distorted signals, and even NASA's occasional silence on the matter as proof of something extraordinary. But in reality, the Black Knight is a reminder of how easily our imaginations can transform the mundane into the extraordinary. This story also opens the door to a broader question: what else is lurking in Earth's orbit? Beyond the Black Knight, there are countless other objects, some identified, others not, that continue to intrigue scientists and enthusiasts alike. From defunct satellites to mysterious flashes of light, our planet's orbit is a crowded and enigmatic place. And while most of these objects have simple explanations, they still fuel our curiosity about what lies beyond our atmosphere. Imagine looking up at the night sky, filled with countless stars, galaxies, and planets, and realizing that despite the sheer vastness of it all, we've yet to find any sign of extraterrestrial life. This is the heart of the Fermi Paradox, a question that has puzzled scientists and thinkers for decades. If the universe is so enormous with billions of potentially habitable planets, where is everyone? Named after physicist Enrico Fermi, who famously posed this question during a casual conversation in the 1950s, the paradox challenges our assumptions about life beyond Earth. One of the most compelling explanations is the idea of the Great Filter, a hypothetical barrier that prevents civilizations from reaching a stage where they can communicate across the cosmos. This filter could exist in our past, meaning that the emergence of intelligent life is so rare that we might truly be alone. Or it could lie ahead of us, suggesting that advanced civilizations inevitably face some catastrophic event that wipes them out before they can make contact. Either way, the implications are both thrilling and terrifying. Another possibility is that intelligent life is simply extraordinarily rare. The conditions required for life to emerge, evolve, and develop technology capable of interstellar communication might be so specific that even in a universe as vast as ours, we're one of the few, or perhaps the only species to reach this point. But what if the answer is even stranger? What if advanced civilizations are out there, but they're deliberately avoiding us, or their methods of communication are so advanced that we can't yet comprehend them? This paradox doesn't just challenge our understanding of the cosmos, it forces us to reflect on our place within it. Are we alone, or is the universe hiding something extraordinary from us? As we ponder this mystery, it's worth remembering that the cosmos is full of anomalies that defy explanation, each one a reminder of how much we still have to learn. And speaking of anomalies, what about those strange signals from deep space that seem to come from nowhere? But that's a story for another moment. Now, let's turn our attention to one of the most profound mysteries in all of science: dark matter and dark energy. These two invisible forces make up a staggering 95% of the universe, yet we can't see them, touch them, or fully understand them. It's like trying to solve a puzzle where most of the pieces are missing. What we do know is that dark matter and dark energy are the hidden architects shaping the cosmos as we know it. Take dark matter, for example. Even though it doesn't emit light or interact with electromagnetic forces, its presence is undeniable. How well galaxies spin at speeds that defy the laws of physics as we understand them. Based on the visible matter we can observe, stars on the outer edges of galaxies should be flung into space. But they aren't. Something invisible, dark matter, is holding them in place, acting like an unseen gravitational glue. Without it, galaxies would simply fly apart. Then there's dark energy, an even more mysterious force. While dark matter holds the universe together, dark energy is doing the opposite. It's pushing the universe apart at an accelerating rate. Imagine blowing up a balloon that never stops expanding, growing faster and faster. That's what dark energy is doing to the fabric of space itself. It's as if the universe has a hidden engine, driving its expansion in ways we can't yet explain. What makes these forces so fascinating is how little we truly know about them. Scientists have been studying them for decades, yet they remain elusive, hiding in plain sight. They don't interact with light or ordinary matter, so traditional tools like telescopes can't detect them directly. Instead, we infer their existence through their effects on the universe. It's like detecting the wind by watching leaves move. You can't see it, but you know it's there. This mystery isn't just a scientific curiosity. It's a reminder of how much we still have to learn about the cosmos. Dark matter and dark energy challenge our understanding of physics, forcing us to rethink the very laws that govern the universe. And while they may be invisible, their impact is anything but. They're shaping the fate of galaxies, stars, and even the universe itself. As we ponder these invisible forces, it's impossible not to wonder what else is out there, hidden in the vast expanse of space. Could there be other unseen phenomena, equally mysterious and equally powerful, waiting to be discovered? The universe is full of secrets, and dark matter and dark energy are just the beginning. Now, let's talk about something that's literally pulling the universe toward it, a cosmic enigma known as the Great Attractor. Picture this: billions of galaxies, including our own Milky Way, are being drawn toward a single point in space at astonishing speeds. But here's the catch: we can't even see what's doing the pulling. Why? Because this gravitational powerhouse lies hidden behind the dense plane of our galaxy, shrouded in stars, gas, and dust. It's like trying to spot a lighthouse through a thick fog. So, what exactly is the Great Attractor? Scientists believe it could be a massive cluster of galaxies, so densely packed that its gravity tugs on everything around it. But here's where it gets even stranger. Some researchers think it might be something far more unusual, something we can't yet explain. Could it be an enormous concentration of dark matter? Or perhaps an entirely new kind of cosmic structure? The truth is, we're still piecing together the puzzle. What we do know is that the Great Attractor isn't alone. It's part of an even larger gravitational web, with superclusters of galaxies interacting in ways that challenge our understanding of the universe. And as we look deeper into these cosmic mysteries, we're reminded just how much we still have to discover. Speaking of gravitational oddities, the Great Attractor is just one piece of a much larger cosmic puzzle. There are other strange forces at work in the universe, bending space and time in ways that continue to baffle us. One such mystery lies in the phenomenon of dark flow, a peculiar force that seems to be pulling entire galaxy clusters in a specific direction, far beyond what we can currently observe. But that's a story for another moment. For now, let's marvel at the Great Attractor, a reminder that even in the vastness of space, there are forces at work that defy our understanding, pulling us toward answers we're only beginning to uncover. Imagine a place in the universe so vast and empty that it feels like a cosmic desert, a region where galaxies are almost non-existent, and the darkness stretches for hundreds of millions of light years. This is the Boötes Void, one of the most baffling and eerie spaces ever discovered. Often referred to as the Great Nothing, This colossal void is located about 700 million light-years from Earth and spans an astonishing 330 million light-years across. To put that into perspective, if the Milky Way were placed at its center, it would take light from our galaxy millions of years just to reach the void's edge. What makes the Boötes Void so perplexing is its sheer emptiness. In a universe teeming with galaxies, stars, and planets, this region defies all expectations. While most parts of the cosmos are filled with clusters and superclusters of galaxies, the Boötes Void contains only a handful of them, less than 60 in total, compared to the thousands you'd expect in such a volume. This stark contrast challenges our understanding of how matter is distributed across the universe. Scientists have long believed that the cosmos follows a kind of cosmic web structure, with galaxies forming along dense filaments and leaving empty voids in between. But the Boötes Void is so extreme that it pushes this model to its limits. So, how did this vast emptiness come to be? One theory suggests that the Boötes Void might be the result of smaller voids merging over billions of years, creating a supervoid that's almost unimaginably large. Another idea proposes that some unknown cosmic process, something beyond our current understanding, could have swept away matter, leaving behind this barren expanse. Some even speculate that it might be evidence of a collision with another universe or the footprint of a long-forgotten cosmic event. Whatever the explanation, the Boötes Void remains a tantalizing mystery, inviting us to rethink what we know about the universe's structure. But the Boötes Void isn't the only strange region out there. The universe is full of oddities that challenge our understanding, from the mysterious cold spot in the cosmic microwave background to the enigmatic Hercules Corona Borealis Great Wall, a colossal structure of galaxies that stretches for billions of light years. Each of these cosmic oddities reminds us that the universe is far stranger and more complex than we can imagine. And as we continue to explore, who knows what other bizarre wonders we might uncover. Now, let's turn our attention to one of the most puzzling objects ever detected in our solar system, Oumuamua. In October 2017, astronomers spotted something extraordinary, a visitor from another star system. Unlike anything we'd seen before, this interstellar object zipped through our solar system at incredible speeds, leaving scientists both amazed and baffled. Its name, Oumuamua, means scout or messenger from afar in Hawaiian, and it certainly lived up to that title. What made Oumuamua so unusual? For starters, its shape. Most asteroids and comets we've observed are roughly spherical or irregular chunks of rock. But Oumuamua, it was long and thin, like a cosmic cigar or a pancake, stretching hundreds of meters in length but only a fraction of that in width. This bizarre shape immediately sparked curiosity. How did something like this form, and why did it behave so strangely as it moved through space? Then there was its acceleration. As Oumuamua traveled away from the Sun, it didn't just coast along as expected. Instead, it sped up, defying the laws of gravity. Normally, comets accelerate due to outgassing when sunlight heats their icy surfaces, releasing gas that acts like a natural thruster. But here's the catch. Oumuamua showed no visible signs of a coma, the glowing cloud of gas and dust that usually surrounds a comet. So, what was pushing it? This mystery led to some wild theories. Some scientists proposed that Oumuamua might be a fragment of a larger object, shattered by some distant cosmic event. Others suggested it could be a rare type of hydrogen iceberg, a chunk of frozen hydrogen that evaporates invisibly as it warms. But perhaps the most tantalizing idea came from Harvard astronomer Avi Loeb, who floated the possibility that Oumuamua wasn't natural at all, but an artificial object, maybe even an alien probe. Of course, the majority of the scientific community leans toward natural explanations. After all, the universe is full of strange phenomena we've yet to fully understand. But Oumuamua's peculiarities remind us that space is far from predictable. It challenges us to think bigger, to question what we know, and to keep searching for answers. And Oumuamua isn't alone. Since its discovery, astronomers have detected other interstellar visitors like the comet Borisov, which passed through in 2019. Each one offers a new piece of the cosmic puzzle, a glimpse into the vast, uncharted territories beyond our solar system. As we continue to explore, who knows what other mysteries are waiting to be uncovered. The pillars of creation, few images in astronomy capture the imagination quite like these towering columns of gas and dust, stretching over light years in the heart of the Eagle Nebula. Captured by the Hubble Space Telescope, they've become an emblem of the universe's beauty and its boundless creativity. But here's the twist: these breathtaking structures might not even exist anymore. That's right, what we see is a snapshot from the past, a glimpse of light that traveled thousands of years to reach us. And by now, a supernova explosion could have already torn through them, obliterating these cosmic masterpieces. The catch: we won't know for sure until the light from that destruction reaches Earth, which could take millennia. This eerie possibility opens up a fascinating question. How many other cosmic wonders are hiding secrets we can't yet see? Take the Crab Nebula, for example. What we observe today is the aftermath of a supernova witnessed by Chinese astronomers in the year 1054. But what if we could see it as it was before the explosion? Or consider the Carina Nebula, a stellar nursery where massive stars are born and die in spectacular fashion, their light carrying stories of events long past. The universe, it seems, is full of time capsules, each one holding secrets that challenge our understanding of time and space. The pillars of creation remind us that the cosmos is not just a static backdrop but a dynamic, ever-changing stage. Even as we marvel at their grandeur, we're left to wonder, what other hidden mysteries lie within the vastness of space, waiting for their stories to unfold? Now, let's turn our attention to one of the most perplexing mysteries in the cosmos, the cosmic microwave background cold spot. This enigmatic region, located in the distant reaches of the universe, is a patch of space that's significantly colder than its surroundings, so cold, in fact, that it defies our current understanding of how the universe works. Imagine the cosmic microwave background, or CMB, as a snapshot of the universe's infancy, a faint afterglow of the Big Bang. Most of it looks uniform, but this cold spot stands out like a sore thumb, challenging the very foundations of cosmology. At first glance, you might think, couldn't this just be a random fluctuation? But here's the twist: the cold spot is so extreme that the odds of it occurring naturally, based on our standard model of the universe, are astronomically low, less than 1 in 100. That's like rolling a 6-sided die 100 times and never landing on a single number. Scientists have proposed some mind-bending theories to explain this anomaly. One idea suggests that the cold spot might be evidence of a collision with another universe, a multiverse scenario where our universe bumped into a neighboring one, leaving behind this cosmic bruise. Another theory points to the possibility of a supervoid, an immense region of space with far fewer galaxies than usual, creating a kind of cosmic vacuum that could explain the temperature drop. But here's the kicker: even these theories have their challenges. A supervoid large enough to cause the cold spot would itself be an anomaly, and the multiverse idea, while thrilling, is still firmly in the realm of speculation. What makes the cold spot so fascinating is that it doesn't just challenge one idea, it forces us to rethink our entire framework of the universe, and it's not the only oddity in the CMB. Other strange patterns and anomalies lurk within this cosmic tapestry, each one a potential clue to unraveling the deeper mysteries of existence. So, as we ponder the cold spot, let's not forget that it's just one piece of a much larger puzzle. The cosmic microwave background is brimming with secrets, and each one invites us to look deeper, to question what we think we know, and to marvel at the infinite complexity of the cosmos. And speaking of cosmic anomalies, the CMB has even more surprises in store, ones that might just reshape our understanding of reality itself. Galaxies, those sprawling cosmic cities of stars, dust, and dark matter, are often seen as serene and unchanging. But the truth is far more dramatic. Picture this, a massive galaxy, billions of times more massive than our Sun, slowly devouring a smaller neighbor. This isn't science fiction, it's a real phenomenon known as galactic cannibalism, and it's happening all across the universe. Take the Andromeda Galaxy, for instance. It's our closest galactic neighbor, and it's on a collision course with the Milky Way. But don't worry, this cosmic crash won't happen for another 4 to 5 billion years. When it does, it won't be a chaotic explosion of destruction. Instead, the two galaxies will merge, their stars and gas clouds gradually intertwining. The larger Andromeda Galaxy, with its immense gravitational pull, will effectively eat the Milky Way, reshaping both into a single, even larger galaxy. Astronomers have even given this future hybrid a name, Milkomda. What's fascinating is that this process isn't unique to Andromeda and the Milky Way. Galactic cannibalism is a common occurrence in the universe. Larger galaxies often consume smaller ones, growing even more massive over time. This process can leave behind ghostly trails of stars, remnants of the smaller galaxy that was absorbed. These tidal tails are like cosmic breadcrumbs marking the path of galactic destruction. But what does this mean for the future of our galaxy? For one, it shows that galaxies aren't static, they're dynamic, ever-changing systems. The Milky Way itself has likely consumed smaller galaxies in the past, and we're seeing evidence of that in the faint streams of stars that orbit our galactic center. These streams are the remnants of ancient galactic meals, a testament to the Milky Way's own cannibalistic tendencies. Galactic cannibalism also has profound implications for how galaxies evolve. By consuming smaller galaxies, larger ones gain new stars, gas, and dust, which can fuel the birth of new stars and even supermassive black holes. It's a cosmic recycling process where the remains of one galaxy become the building blocks of another. This phenomenon isn't just about destruction, it's also about creation, and it raises even more questions. What happens to the supermassive black holes at the centers of these merging galaxies? Do they collide, or do they orbit each other in a cosmic dance? What happens to the planets orbiting stars in the smaller galaxy? While we don't have all the answers, these mysteries keep astronomers captivated, pushing the boundaries of what we know about the universe. And speaking of mysteries, galactic cannibalism is just one of many bizarre phenomena in the cosmos. From rogue planets wandering alone in the void to enigmatic fast radio bursts that flash across the sky, the universe is full of wonders that defy explanation. Each discovery reminds us just how much we have yet to learn. So, as we ponder the fate of the Milky Way and Andromeda, let's not forget the cosmos is vast, strange, and endlessly fascinating. What other secrets are waiting to be uncovered? Deep in the cosmos, about 40 light-years from Earth, lies a world that sounds like it belongs in a science fiction novel, a planet made largely of diamond. Known as 55 Cancri, this exotic exoplanet orbits a star in the constellation Cancer, and its very existence challenges everything we thought we knew about planetary formation. Imagine a world where the ground beneath your feet isn't rock or ice, but pure carbon crystallized into one of the universe's most precious materials. But how does such a planet even come to exist? 55 Cancri is what scientists call a super-Earth, a term that might sound comforting, but don't let it fool you. This planet is far from hospitable, with surface temperatures soaring to thousands of degrees and a year that lasts just 18 hours. It's a place where the very concept of habitability is turned on its head. Its diamond-like composition is the result of extreme pressure and heat, which have transformed the planet's carbon-rich interior into a crystallized treasure trove. To put it simply, this isn't just a planet, it's a cosmic jewel, forged under conditions so intense they defy imagination. But what does a diamond planet mean for our understanding of the universe? For one, it forces us to rethink the diversity of planetary systems. We often assume planets form in ways similar to those in our own solar system, with rocky worlds like Earth or gas giants like Jupiter. Yet, 55 Cancri stands as a stark reminder that the universe is far more creative and unpredictable than we give it credit for. Its existence opens up new possibilities for studying exoplanets, suggesting that there may be countless other worlds out there with compositions and conditions we've yet to even dream of. And speaking of other worlds, 55 Cancri is just the tip of the cosmic iceberg. Beyond this glittering enigma, the universe is filled with planets that push the boundaries of what we consider normal. From worlds that rain glass sideways to planets with skies that never see a sunset, the cosmos is a treasure chest of bizarre and wondrous phenomena. But that's a story for another moment, because next we'll uncover a planet so strange it makes 55 Cancri look almost ordinary. Now, let's turn our attention to one of the most baffling stellar enigmas ever observed, the so-called zombie star. This cosmic oddity comes from the story of Tycho's supernova, a star that seemingly died in a spectacular explosion, only to reignite and defy the very laws we thought governed stellar life cycles. Back in 1572, astronomers witnessed a bright new star appear in the constellation Cassiopeia, shining so intensely that it could be seen even during the day. At first, it was assumed to be a typical supernova, a star reaching the end of its life in a brilliant, catastrophic burst. But what happened next left scientists scratching their heads. Centuries later, observations of the same region revealed something extraordinary. Remnants of the explosion were still active, emitting energy as if the star had never truly died. This zombie star has forced us to rethink what we know about stellar death. Traditionally, stars are thought to follow a predictable path. They burn through their fuel, expand, and eventually collapse or explode, leaving behind a neutron star, black hole, or a fading cloud of gas. But Tycho's supernova didn't follow the script. Instead, it reignited, challenging the very definition of what it means for a star to die. This phenomenon isn't just a one-off. Other stars have also defied expectations, like the mysterious Eta Carinae, a hypergiant star that has experienced multiple violent eruptions without fully collapsing. Then there's the case of the luminous blue variables, stars that teeter on the edge of destruction, flaring up unpredictably and refusing to go quietly into the cosmic night. These cosmic rebels remind us that the universe is far more dynamic and unpredictable than we often assume. Every time we think we've figured out the rules, space throws us a curveball, forcing us to question and expand our understanding. Now, let's turn our attention to one of the most baffling features in our solar system, Saturn's mysterious hexagon. Nestled at the planet's north pole, this colossal six-sided storm is unlike anything else we've ever observed in nature. Imagine a swirling jet stream, but one that's perfectly geometric, stretching over 20,000 miles wide, large enough to engulf nearly 4 Earths. This bizarre hexagon has been spinning for decades, if not centuries, and its precise, angular shape defies everything we know about planetary weather patterns. On Earth, storms and atmospheric systems are chaotic and unpredictable, shaped by turbulence and uneven forces. But Saturn's hexagon is eerily symmetrical, with 6 nearly identical sides that maintain their shape over time. So, how does a planet produce such a perfect geometric storm? Scientists have proposed several theories, from standing wave patterns in the atmosphere to the influence of Saturn's rapid rotation, which completes a day in just about 10.5 hours. Some even suggest that the hexagon might be the result of deep-seated fluid dynamics, where layers of gas interact in ways we're only beginning to understand. Yet, despite decades of observation and study, the true cause of this phenomenon remains shrouded in mystery. What makes this hexagon even more intriguing is its persistence. Unlike Earth's hurricanes or Jupiter's Great Red Spot, which evolve and fade over time, Saturn's hexagon has remained remarkably stable. The Cassini spacecraft, which studied Saturn up close until 2017, captured stunning images of this structure, revealing its intricate cloud patterns and how it interacts with the planet's atmosphere. But even with all that data, we're still left with more questions than answers. Why 6 sides? Why not 5, 7, or even a more chaotic shape? And what keeps it so perfectly aligned over such a vast area? This hexagonal storm is a reminder of how much we still have to learn about the cosmos. It challenges our understanding of planetary atmospheres and forces us to rethink the boundaries of what's possible in nature. And while Saturn's hexagon is one of the most striking examples, it's far from the only planetary oddity out there. From the chaotic storms of Neptune to the icy geysers of Enceladus, our solar system is full of mysteries that continue to defy explanation. And who knows, maybe the answers to these puzzles are waiting just beyond the next discovery. But let's not stop there, because the red rectangle is just one piece of a much larger cosmic puzzle. It's a reminder that the universe loves to defy expectations, and it's not the only strangely shaped object out there. Take, for instance, the Hourglass Nebula with its pinched waist and glowing rings, or the bizarre Boomerang Nebula, which holds the title of the coldest place in the known universe. These structures, like the red rectangle, push the boundaries of what we thought was possible, forcing us to rethink how stars and planetary systems evolve. Each one is a cosmic anomaly, a testament to the fact that the universe is far stranger and far more creative than we ever imagined. And as we continue to explore these oddities, one thing becomes clear: the universe isn't just a place of chaos and randomness. It's a place of patterns, puzzles, and endless surprises waiting for us to uncover their secrets. Picture this: a colossal hand stretching across the void of space, its glowing fingers reaching out as if to grasp something unseen. This is no work of science fiction, it's the hand of God, a nebula that has stunned astronomers and captured the imagination of the public. Officially known as a pulsar wind nebula, this eerie formation resembles a human hand so vividly that it's hard not to feel a chill when you see it. Located about 17,000 light-years from Earth, the Hand of God is powered by the remains of a massive star that exploded in a supernova, leaving behind a rapidly spinning neutron star. The energy from this pulsar interacts with surrounding gas and dust, creating the ghostly glow that forms the hand. But what makes this nebula so hauntingly hand-like? Scientists believe it's a combination of perspective and the intricate interplay of magnetic fields and charged particles. The pulsar's intense radiation pushes and shapes the surrounding material, sculpting it into a form that, from our vantage point, looks eerily familiar. Yet, despite our understanding of the physics at play, the Hand of God remains a cosmic enigma. Why does it take on such a strikingly human shape? Is it simply a trick of perspective, or is there something more profound at work? These questions linger, reminding us that even with all our advancements, the universe still holds mysteries that defy easy explanation. The Hand of God isn't just a scientific curiosity, it's a reminder of how space can stir our emotions and spark our imaginations. It's as if the cosmos itself is reaching out, inviting us to ponder the deeper questions about our place in the universe. And while this ghostly hand may be one of the most visually striking phenomena, it's far from the only eerie sight in the cosmos. From glowing clouds of ionized gas to remnants of ancient stellar explosions, space is filled with ghostly wonders that continue to captivate and mystify us. Imagine looking at the night sky and realizing that everything out there, every galaxy, every star cluster might be moving in a way we can't fully explain. This isn't science fiction, it's a real phenomenon scientists call dark flow. Picture this: massive galaxy clusters, each containing hundreds or even thousands of galaxies, all being pulled in the same direction at incredible speeds. But here's the kicker: there's no visible force or object causing this movement. It's as if the universe itself has a hidden current, and we're only just beginning to notice it. Dark flow was first detected by studying the cosmic microwave background, the faint afterglow of the Big Bang. Researchers noticed that galaxy clusters were moving in a way that couldn't be explained by the known laws of gravity or the distribution of matter in the observable universe. Some scientists speculate that this mysterious pull might be coming from something beyond our universe, perhaps a neighboring universe or a region of space we can't yet see. Others suggest it could be evidence of a flaw in our understanding of gravity itself. Either way, dark flow is a cosmic puzzle that challenges everything we think we know about how the universe works. What makes dark flow even more intriguing is how it connects to other unexplained movements in the cosmos. For instance, there's the Great Attractor, a gravitational anomaly pulling galaxies toward it, including our own Milky Way. Then there's the Shapley supercluster, an enormous concentration of galaxies that might also be influencing the motion of galaxy clusters. Could these phenomena be linked to dark flow? Or are they entirely separate mysteries, each hinting at a deeper layer of cosmic complexity we're only starting to unravel? The idea of dark flow forces us to ask bigger questions about the nature of the universe. Are there forces at play that we can't yet detect? Could there be entire regions of space or even other universes exerting a gravitational influence on ours? And if so, what does that mean for our understanding of reality? These questions don't just challenge scientists, they invite all of us to rethink our place in the cosmos. After all, if the universe is full of movements and forces we can't yet explain, what other surprises might be waiting for us out there? As we continue to explore these cosmic mysteries, one thing is clear: the universe is far stranger and more dynamic than we ever imagined. Dark flow is just one piece of a much larger puzzle, reminding us that even in the vastness of space, there's always more to discover. Imagine this: a planet that's cold, barren, and seemingly lifeless, yet it holds a secret that could change everything we know about life beyond Earth. That secret is methane, a gas that's been detected on Mars, and its presence has left scientists scratching their heads. Methane isn't just any gas on Earth, it's often produced by living organisms, which makes its discovery on Mars incredibly intriguing. Could this be a sign of microbial life lurking beneath the Martian surface? Or is there another explanation that we haven't figured out yet? The mystery deepens when you consider how methane behaves. On Mars, the gas doesn't stick around for long, it breaks down quickly under the planet's harsh conditions. So if methane is being detected, something must be replenishing it. Scientists have proposed a few theories. It could be produced by geological processes like interactions between water and rocks, or it might indeed be the byproduct of tiny Martian microbes. But here's the kicker: despite years of observation, the methane appears sporadically, making it nearly impossible to pinpoint its source. It's like trying to solve a puzzle with half the pieces missing. This enigma has sparked heated debates in the scientific community. Some argue that the methane could be a false signal, caused by instruments or even contamination from Earth. Others believe it's the strongest clue yet that Mars harbors life, even if it's just microscopic. The stakes are high because if methane is linked to life, it would mean we're not alone in the universe, and Mars might just be the place to prove it. But until we can send more advanced missions to dig deeper into the Martian soil or study its atmosphere in greater detail, the mystery of Martian methane will remain unsolved. And Mars isn't the only place in our solar system where we're searching for signs of life. From the icy moons of Jupiter and Saturn to the distant reaches of Pluto, the hunt is on. Each discovery, whether it's methane on Mars or plumes of water vapor on Europa, brings us one step closer to answering the ultimate question: are we alone in the cosmos? Far out in the cold reaches of our solar system, Saturn's moon Enceladus hides a secret beneath its icy shell. A secret that might just change how we think about life beyond Earth. Imagine a world where towering geysers of water vapor shoot hundreds of miles into space, creating a shimmering halo around the moon. These aren't just any geysers, they're the Enceladus plumes, and they're one of the most tantalizing mysteries in our cosmic backyard. What makes these plumes so extraordinary is what they're hiding. Scientists believe they're evidence of a vast subsurface ocean buried beneath miles of ice. This isn't just a stagnant pool of water, it's a dynamic, possibly habitable environment. The plumes contain not only water vapor but also organic molecules, the building blocks of life, and even hints of hydrothermal activity. In other words, Enceladus might have all the ingredients needed to support life as we know it. But Enceladus isn't alone in this cosmic game of hide and seek. Its discovery has sparked a wave of curiosity about other moons that might also harbor hidden oceans. Take Europa, one of Jupiter's largest moons, for example. Its cracked, icy surface hints at a global ocean beneath, one that could be twice the volume of all Earth's oceans combined. Or consider Titan, Saturn's largest moon, with its thick atmosphere and lakes of liquid methane. While it's not water, the complex chemistry on Titan raises intriguing questions about alternative forms of life. What's truly fascinating is how these moons challenge our understanding of where life could exist. For decades, we've focused our search on planets within the habitable zone, the region around a star where temperatures could allow liquid water to exist on a planet's surface. But moons like Enceladus and Europa show us that life might be thriving in the most unexpected places, far from the warmth of a star in the frigid depths of icy worlds. So what's next? Missions like NASA's upcoming Europa Clipper aim to explore these mysterious oceans in more detail. Could we one day find microbial life swimming in the dark waters of Enceladus or Europa? The possibility is as thrilling as it is profound. These moons remind us that the universe is full of surprises, and sometimes the most promising places to look for life are the ones we least expect. Now, let's turn our attention to one of the most baffling events in modern history, the Tunguska Event. Picture this: on June 30th, 1908, in the remote forests of Siberia, an explosion of unimaginable force rocked the Earth. The blast was so powerful that it flattened over 2,000 square kilometers of forest, an area roughly the size of a major city. Trees were knocked down like matchsticks, radiating outward from the epicenter in a pattern that still baffles scientists today. But here's the twist: there was no crater, no smoking gun, just a vast, eerie landscape of destruction with no obvious cause. So what could have caused such a cataclysmic event? Over the years, theories have ranged from the plausible to the downright fantastical. Some suggest it was a comet or asteroid exploding in the atmosphere, releasing energy equivalent to hundreds of atomic bombs. Others propose more exotic explanations, like a black hole passing through Earth or even an alien spacecraft meeting a fiery end. Yet, despite decades of research, the Tunguska Event remains a mystery. No fragments of a cosmic intruder have ever been found, and the true nature of the explosion continues to elude us. But the Tunguska Event isn't just a historical curiosity. It's a reminder of how unpredictable and powerful the universe can be. Imagine if such an explosion had occurred over a populated area instead of a remote forest. The consequences would have been catastrophic. And while we may never know exactly what happened that day in Siberia, it raises an important question. How many other cosmic surprises are lurking out there, waiting to defy explanation? As we ponder this, let's turn our gaze to another celestial mystery, one that involves not just a single event, but an entire cosmic phenomenon that has left scientists scratching their heads. This next story takes us even deeper into the unknown, where the rules of physics seem to bend and the universe reveals its strangest secrets. Did you know that the Moon, our closest cosmic neighbor, once had a magnetic field strong enough to rival Earth's? It's a fact that sounds almost too strange to be true, but billions of years ago, the Moon wasn't just a barren rock, it was a dynamic world with its own magnetic shield. This ancient magnetic field has left scientists scratching their heads because the Moon, as far as we know, shouldn't have been able to generate one in the first place. Unlike Earth, which has a molten iron core that spins to create its magnetic field, the Moon's core is much smaller and cooler. So, how did it manage to produce such a powerful magnetic force? This lunar magnetic mystery isn't just a curiosity, it's a puzzle that could rewrite our understanding of the Moon's history. Some researchers believe that the Moon's magnetic field might have been powered by a completely different mechanism, like massive impacts or even a temporary high-energy core activity. Others suggest that the Moon's early environment, perhaps filled with molten material and intense heat, played a role. Whatever the cause, this magnetic field vanished around 1 billion years ago, leaving behind faint traces in lunar rocks that we've only recently been able to detect. But the Moon's magnetic field is just the tip of the iceberg when it comes to lunar mysteries. For instance, why does the Moon have regions with highly concentrated gravity, known as mass concentrations or mascons, that make spacecraft orbit wobble unpredictably? Or what about the strange flashes of light that have been observed on its surface for centuries? Are they just meteor impacts, or could there be something more unusual going on? Each of these enigmas reminds us that, even after decades of exploration, the Moon still holds secrets that defy explanation. As we continue to study these lunar puzzles, one thing becomes clear: the Moon isn't just a silent companion in our night sky. It's a time capsule, preserving clues about the early solar system and challenging us to rethink what we thought we knew about its origins and evolution. And who knows, the answers to these mysteries might not just teach us about the Moon. They could reveal something profound about our own planet and even the universe itself. But let's shift our gaze from the strange and isolate it to something far more expansive, something that binds the universe together in an intricate, almost artistic design. Have you ever wondered what holds the cosmos in place? What invisible threads weave through the vast emptiness, connecting galaxies and clusters across unfathomable distances? The answer lies in something called the cosmic web. This isn't just a poetic term, it's the very backbone of our universe. Picture a colossal, three-dimensional spiderweb, but instead of silk, it's made of dark matter and gas stretching across billions of light years. These filaments form a network so vast and complex that it defies imagination, connecting galaxies in a delicate balance of gravity and cosmic forces. These are not just random strands, they are the highways of the universe, guiding the flow of matter and energy on a scale that's almost impossible to comprehend. What's truly mind-bending is how this structure challenges our understanding of cosmic evolution. The cosmic web suggests that the universe isn't just a random scattering of galaxies, it's a meticulously organized system, shaped by forces we're still struggling to fully understand. Dark matter, which makes up the bulk of this web, doesn't interact with light or ordinary matter, yet its gravitational influence is what gives the universe its structure. And the gas flowing through these filaments, it's the raw material for new stars and galaxies, fueling the endless cycle of creation and destruction that defines our cosmos. But here's the kicker: the cosmic web isn't just a static framework. It's alive in a cosmic sense, constantly evolving and shifting as gravity pulls matter into denser regions, forming galaxy clusters and leaving vast voids in between. These voids, often spanning hundreds of millions of light years, are some of the emptiest places in existence, yet they're just as important to the web's structure as the dense filaments themselves. The more we study the cosmic web, the more questions arise. How did it form so early in the universe's history? What role did dark energy play in shaping its vast expanse? And how do these filaments influence the galaxies we see today? It's a reminder that, even on the largest scales, the universe is full of mysteries waiting to be unraveled. And speaking of large-scale structures, the cosmic web is just one piece of a much bigger puzzle. From superclusters to walls of galaxies, the universe is filled with formations that make even the cosmic web seem like a small part of an even grander design. But what if I told you there's a hidden giant lurking in the shadows of our solar system, one that we've never actually seen but could be shaping the orbits of distant worlds? This brings us to the enigma of Planet 9, a hypothetical planet that's been the subject of intense speculation and fascination among astronomers. The idea isn't just science fiction, there's compelling evidence suggesting something massive is out there, tugging at the edges of our cosmic neighborhood. The story of Planet 9 begins with strange anomalies in the orbits of distant objects beyond Neptune. These icy bodies, known as trans-Neptunian objects, seem to cluster in ways that can't be explained by the known planets alone. Their paths are oddly aligned, as if influenced by the gravitational pull of something much larger. That's where Planet 9 comes into the picture, a potential super-Earth up to 10 times the mass of our own planet, orbiting far beyond Pluto. Yet, despite decades of searching, Planet 9 remains a ghost. Its distance from the Sun, estimated to be hundreds of times farther than Earth's orbit, makes it incredibly difficult to detect. The faint light it might reflect is drowned out by the vastness of space. It's like trying to spot a single candle flame in a city lit by a billion lights. And yet, the hunt continues, with telescopes scanning the skies for any hint of this elusive world. What makes this mystery even more intriguing is what it could tell us about the early solar system. If Planet 9 exists, it might be a relic from a time when planets were still forming, flung outward by gravitational interactions billions of years ago. It could hold clues about how our solar system evolved and why certain objects ended up where they are today. But Planet 9 isn't the only hypothetical object out there. The edges of our solar system are a treasure trove of mysteries, from rogue planets wandering the void to the possibility of a massive black hole hiding in the darkness. Each of these ideas challenges our understanding of the cosmos and reminds us just how much we have yet to discover. The search for Planet 9 isn't just about finding another planet, it's about uncovering the secrets of our universe's deepest corners. Imagine a light so intense that it outshines an entire galaxy, billions of stars combined. That's the power of a quasar, one of the most luminous objects in the universe. These cosmic beacons are fueled by supermassive black holes, but they don't just sit quietly in the void. Instead, they devour matter at an astonishing rate, releasing energy so immense that it challenges everything we think we know about black holes. Quasars, short for quasi-stellar radio sources, appear as tiny points of light, almost like stars when viewed from Earth, but don't let their modest appearance fool you. At their core lies a supermassive black hole, millions or even billions of times more massive than our Sun. As gas, dust, and even stars spiral into the black hole, they form a swirling disk of superheated material. This disk glows so brightly that it can be seen across billions of light years. What makes quasars truly bizarre is their energy output. They can emit more light than an entire galaxy, all from a region no larger than our solar system. This defies our understanding of how black holes behave. Conventional wisdom suggests that black holes are cosmic vacuums, pulling everything in and letting nothing escape, not even light. Yet quasars prove that black holes are far more dynamic. They're not just destructive forces, they're also creators, generating some of the most powerful energy bursts in the cosmos. Scientists are still piecing together how quasars work. How can a black hole, known for its gravitational grip, produce such intense radiation? The answer lies in the chaotic environment around the black hole. As matter spirals inward, friction and magnetic fields heat it to billions of degrees, causing it to glow and emit jets of high-energy particles. These jets can stretch for thousands of light years, carving through space like cosmic lasers. But quasars are more than just a scientific curiosity. They're also cosmic time capsules. Because light takes time to travel, the quasars we observe today are snapshots of the early universe, when galaxies were young and black holes were voraciously feeding. They offer clues about how galaxies form and evolve, and how supermassive black holes grow to such staggering sizes. And just when you think you've grasped the enormity of quasars, another mystery emerges. Why do some supermassive black holes become quasars while others remain dormant? What triggers these outbursts of energy, and why do they eventually fade? The answers to these questions could reshape our understanding of the universe's most enigmatic objects. Speaking of black hole mysteries, there's another cosmic puzzle that's equally baffling, one that involves not light but silence. A phenomenon so strange that even the most brilliant minds struggle to explain it, but we'll save that for the next section. Now, let's turn our attention to one of the most intriguing mysteries in modern cosmology, the Hubble Tension. Imagine this: scientists have two reliable ways to measure how fast the universe is expanding, yet these methods keep giving us different answers. It's like using two perfectly calibrated thermometers to check the temperature of the same room, only to find one says it's warm and the other insists it's chilly. This discrepancy, known as the Hubble Tension, has left astrophysicists scratching their heads and rethinking our understanding of the cosmos. The first method relies on observing distant stars and supernova, using their brightness to calculate how quickly they're moving away from us. This gives us a specific value for the universe's expansion rate, known as the Hubble constant. The second approach looks at the afterglow of the Big Bang, the cosmic microwave background, and uses it to predict how fast the universe should be expanding today. The problem: these two methods don't agree. They're off by just enough to suggest that something fundamental might be missing from our current model of the universe. This tension isn't just a minor hiccup, it's a direct challenge to the standard model of cosmology, which has been the backbone of our understanding for decades. Could there be unknown forces at play, or perhaps our measurements are missing something crucial, like dark energy behaving in ways we haven't predicted? Some scientists even speculate that entirely new physics might be needed to resolve this puzzle. The Hubble tension isn't just a scientific problem, it's an invitation to explore the deeper, hidden layers of reality. And this mystery isn't alone. It's part of a growing list of cosmic puzzles that keep researchers up at night. From the strange behavior of dark matter to the perplexing nature of dark energy, the universe seems to enjoy keeping us on our toes. Each of these enigmas pushes the boundaries of what we know, reminding us that the cosmos is far more complex and far more fascinating than we've ever imagined. So, as we grapple with the Hubble tension, we're not just solving one problem, we're opening the door to a universe of questions waiting to be answered. Out in the vast expanse of the cosmos, nestled within the constellation Libra, lies a celestial enigma that has sparked both hope and debate among astronomers, Gliese 581g. Discovered in 2010, this exoplanet orbits within the habitable zone of its red dwarf star, Gliese 581, a region where conditions might just be right for liquid water and potentially life to exist. But here's where things get intriguing. Gliese 581g's very existence is shrouded in uncertainty. While some researchers are confident it's there, others argue that the signals detected could simply be noise or the result of stellar activity. So, what makes this distant world so controversial? The challenge lies in how we detect exoplanets like Gliese 581g. Most are found using the radial velocity method, which measures the slight wobble of a star caused by the gravitational tug of an orbiting planet. But red dwarf stars like Gliese 581 are notoriously active with flares and magnetic storms that can mimic the signals of a planet. This makes it incredibly difficult to separate fact from cosmic interference. Despite multiple studies, the scientific community remains divided, with some teams claiming definitive evidence and others dismissing it as a false alarm. What's fascinating, though, is that even if Gliese 581g does exist, it's no ordinary world. Its orbit is likely tidally locked, meaning one side perpetually faces its star while the other remains in eternal darkness. This creates extreme temperature contrasts with a scorching day side and a freezing night side. Yet, in the twilight zone between these two extremes, conditions might be just right for life to take hold. It's a tantalizing possibility, one that keeps astronomers eagerly searching for more data. But Gliese 581g isn't the only exoplanet wrapped in mystery. The hunt for habitable worlds has turned up several controversial candidates, each with its own story of discovery and debate. Some, like Proxima Centauri b, have sparked excitement, while others, like Fomalhaut b, have faded into obscurity after further scrutiny. Each of these worlds reminds us just how complex and challenging the search for life beyond Earth can be. And as our technology improves, who knows what other cosmic surprises might be waiting for us in the depths of space. Deep within the heart of our Milky Way lies a phenomenon so powerful, yet so enigmatic that it challenges our understanding of the cosmos itself. Galactic superwaves, periodic bursts of cosmic radiation emanating from the galaxy's core, are one of the most puzzling mysteries in space science. These waves are not your everyday cosmic events. They're colossal surges of energy capable of traversing vast distances and potentially reshaping the environments they encounter. But what exactly causes them, and could they pose a threat to our planet? While scientists have theories, the true nature of galactic superwaves remains shrouded in mystery. Some believe they're triggered by massive outbursts from the supermassive black hole at the center of the Milky Way, while others suggest they might be linked to rare cosmic collisions or even the remnants of ancient stellar explosions. What we do know is that these waves carry an extraordinary amount of energy, and if one were to reach Earth, the consequences could be profound. From disrupting satellite communications to altering our planet's climate, the potential impacts are both fascinating and unsettling. But galactic superwaves aren't just a scientific curiosity. They're a reminder of how little we truly understand about the forces that shape our universe. Cosmic radiation in all its forms continues to baffle researchers. From mysterious gamma-ray bursts to unexplained high-energy particles, the cosmos is filled with phenomena that defy explanation. Each discovery raises new questions, pushing us to rethink what we know about the fabric of space and time. These superwaves also serve as a bridge to a broader discussion about cosmic radiation. How does it influence the evolution of galaxies? Could it play a role in the emergence of life? And what other secrets are hidden within these invisible waves of energy? As we continue to probe the depths of space, one thing is certain: the mysteries of the universe are as vast and intricate as the cosmos itself. Imagine staring into the vastness of space and suddenly spotting something that looks like a cosmic smoke ring, only it's not smoke at all. These are odd radio circles, or ORC, and they are one of the most baffling discoveries in recent years. Detected in radio waves, these enormous circular structures stretch across galaxies, yet their origin and purpose remain a complete mystery. Scientists first stumbled upon them in 2020, and since then they've been scratching their heads, trying to figure out what could possibly create such massive, perfectly round formations. What makes ORCs so intriguing is their sheer size. Some are so large they could easily engulf entire galaxies. And here's the kicker: they don't seem to emit any visible light. They're invisible to traditional telescopes, only revealing themselves in radio wavelengths. Some theories suggest they might be shock waves from colossal explosions, leftovers from supernova, or even echoes of supermassive black hole activity. But none of these explanations fully account for their scale or symmetry. It's as if the universe is drawing giant, invisible circles in the sky, and we have no idea why. What's even more fascinating is that ORCs aren't isolated events. Multiple ORCs have been spotted, each with eerily similar characteristics, yet no two are exactly alike. This raises the question: are they a natural phenomenon we've never encountered before, or could they be signs of something far more extraordinary, something we don't yet have the tools or knowledge to understand? And while ORCs are puzzling enough on their own, they're just one piece of the cosmic radio puzzle. The universe is filled with strange signals and unexplained phenomena, each one a clue waiting to be unraveled. From mysterious repeating bursts to eerie whispers in the void, the radio spectrum holds secrets that could rewrite our understanding of space itself. Imagine a world where the night sky is lit not by the steady glow of a sun, but by the rapid flashes of a spinning stellar corpse. This isn't science fiction, it's the reality of the pulsar planets. These bizarre worlds orbit pulsars, the dense, spinning remnants of massive stars that exploded in violent supernovas. But here's the twist: the very existence of these planets defies everything we thought we knew about how planets form. Pulsars are essentially neutron stars, the collapsed cores of stars that once burned brightly but have since met their fiery end. They spin at incredible speeds, emitting beams of radiation that sweep across the cosmos like cosmic lighthouses. When astronomers first discovered planets orbiting these pulsars in the early 1990s, it was nothing short of revolutionary. How could planets survive the cataclysmic explosion that created the pulsar in the first place? And if they didn't survive, how did they form in such an extreme environment? One leading theory suggests that these planets might be the second generation of worlds formed from the debris left behind after the supernova. Picture this: a star explodes, scattering its remains into space. Over time, the leftover material clumps together, forming new planets in the shadow of the pulsar. It's a cosmic recycling program on a scale that's almost impossible to fathom. But this raises even more questions. What could life be like on a planet bathed in intense radiation, with no traditional sun to warm its surface? The pulsar planets aren't just scientific curiosities, they're windows into the resilience and adaptability of planetary systems. Their discovery has forced us to rethink the rules of planetary formation, showing us that planets can emerge in some of the most hostile environments imaginable. And if planets can form around pulsars, what other exotic systems might be out there, waiting to challenge our understanding even further? This leads us to consider other strange worlds that push the boundaries of what we thought was possible. From planets orbiting binary stars to rogue planets drifting through the void of interstellar space, the universe is full of surprises that remind us just how little we truly know. The pulsar planets are just the beginning of a much larger story, one that continues to unfold with every new discovery. Now, let's venture into one of the most perplexing enigmas in the cosmos, the dark galaxy. Imagine a galaxy that's almost invisible, not because it's hiding in the shadows, but because it's made up almost entirely of something we can't see: dark matter. These dark galaxies are like cosmic ghosts lurking in the vastness of space, defying everything we thought we knew about how galaxies form and evolve. Unlike typical galaxies, which are filled with stars, gas, and dust that light up the night sky, dark galaxies are eerily empty of visible matter. They're composed primarily of dark matter, a mysterious substance that doesn't emit, absorb, or reflect light, yet exerts a gravitational pull strong enough to shape the universe. Scientists have theorized their existence for decades, but confirming their presence has been a monumental challenge. How do you detect something that's, by definition, invisible? One of the most compelling pieces of evidence came from observations of gravitational lensing. When light from a distant object bends around a massive object in space, it creates a kind of cosmic magnifying glass. In some cases, this bending of light suggests the presence of a massive structure like a galaxy, but when astronomers point their telescopes at the spot, there's nothing visible there. This mismatch between gravitational influence and visible matter points to the existence of dark galaxies. What makes these ghostly structures so fascinating is how they challenge our understanding of galaxy formation. We've always assumed that galaxies need stars and gas to form and grow, but dark galaxies seem to defy that rule. They exist without the usual building blocks, suggesting that dark matter might play a far more significant role in shaping the cosmos than we ever imagined. Could these dark galaxies be the missing link in our understanding of the universe's large-scale structure? The answer might rewrite the textbooks. And speaking of dark matter, this cosmic puzzle doesn't stop with dark galaxies. The universe is filled with other mysteries tied to this elusive substance, from its role in the formation of supermassive black holes to its influence on the fate of the cosmos itself. But that's a story for another section. For now, let's keep our eyes on the invisible and marvel at the secrets it holds. Out in the vast expanse of the universe, there's a phenomenon so powerful and mysterious that it defies our understanding of physics: ultra-high-energy cosmic rays. These aren't your ordinary cosmic rays, these are the heavyweights of the cosmic world, packing enough energy to rival a well-aimed baseball pitch. But here's the kicker: they're coming from outside our galaxy, and we have no idea what's creating them. Imagine something so energetic that it travels billions of light years across the universe, only to slam into Earth's atmosphere with a force we can barely comprehend. Yet, despite their immense power, detecting these cosmic rays is like trying to catch a whisper in a hurricane. They're fleeting, rare, and maddeningly elusive. Scientists have been working for decades to trace their origins, but the sources remain shrouded in mystery. What makes this puzzle even more fascinating is the sheer scale of energy we're dealing with. These cosmic rays carry millions of times more energy than anything we can produce in our most advanced particle accelerators. Some theories suggest they might come from supermassive black holes, violent galactic collisions, or even exotic objects we haven't discovered yet. But so far, the evidence is inconclusive. This cosmic mystery ties into a broader question: what other high-energy phenomena are lurking out there, waiting to be discovered? From gamma-ray bursts to quasars, the universe is full of extreme events that challenge our understanding of physics. Ultra-high-energy cosmic rays are just one piece of a much larger puzzle, reminding us how much we still have to learn about the cosmos. And while we may not have all the answers yet, each detection brings us closer to unraveling the secrets of these cosmic enigmas. Who knows, the next breakthrough might be just around the corner, waiting to rewrite the textbooks and redefine our understanding of the universe. Picture this, a distant world not unlike our own with a tiny companion orbiting it in the vast darkness of space. This is the tantalizing possibility of an exomoon, a moon outside our solar system, circling a planet far beyond our reach. The idea alone sparks curiosity, but what makes this discovery so elusive? The hunt for the first confirmed exomoon has been one of the most challenging quests in modern astronomy, and it's a mystery that continues to baffle scientists. Detecting an exomoon is no small feat. Imagine trying to spot a firefly hovering next to a streetlight from thousands of miles away. That's the level of difficulty astronomers face. Exoplanets themselves are hard enough to find, but their moons are even smaller, dimmer, and often lost in the glare of their parent stars. The first potential exomoon candidate, known as Kepler 1625b, was detected using data from the Kepler Space Telescope. It appeared to cause subtle dips in starlight as it passed in front of its star, hinting at its presence, but confirming it. That's where things get tricky. The signals are so faint and the data so complex that even the most advanced telescopes struggle to provide definitive proof. What makes this mystery even more intriguing is the possibility that such moons could harbor conditions for life. Imagine a moon with oceans, atmospheres, or even volcanic activity, worlds so far away, yet so familiar in their potential. But until we can confirm their existence, these ideas remain in the realm of speculation. The search for exomoons pushes the boundaries of our technology and imagination, reminding us just how much we still have to learn about the cosmos, and Kepler 1625b is just the beginning. Astronomers are now scanning the skies for other potential exomoon candidates, each with its own unique story waiting to be uncovered. Could there be dozens, even hundreds of these hidden worlds out there? The answer lies in the stars, and the mystery of the exomoon is just one piece of the puzzle. As we continue to explore, who knows what other bizarre and awe-inspiring discoveries await us in the depths of space. Imagine a particle so tiny and elusive that it can pass through an entire planet without ever bumping into a single atom. These ghostly particles are called neutrinos, and while they're incredibly common, billions pass through you every second. They hold secrets that have left scientists scratching their heads. Among the most baffling are the high-energy neutrinos detected here on Earth, particles so powerful that their origins remain one of the greatest mysteries in astrophysics. Unlike most neutrinos, which come from relatively nearby sources like the Sun or supernova, these high-energy neutrinos pack an incredible punch. They're thought to originate from some of the most violent events in the universe: black holes, neutron star collisions, or even phenomena we haven't discovered yet. But here's the catch: despite their immense energy, neutrinos are almost impossible to track back to their source. They don't carry an electric charge, so they're unaffected by magnetic fields, and they interact so weakly with matter that they can travel billions of light years without being disturbed. It's like trying to follow a shadow in complete darkness. No matter how hard you look, it slips away. This cosmic neutrino mystery isn't just about where these particles come from. It's also a window into the extreme environments of the universe. High-energy neutrinos are messengers from the most chaotic and energetic places in existence, offering clues about the forces at play in the depths of space. Yet, every time we detect one, it feels like we're handed a piece of a puzzle without knowing what the final picture should look like. And neutrinos aren't the only particles that keep scientists up at night. Space is filled with other enigmatic particles and phenomena that challenge our understanding of physics. From dark matter, which makes up most of the universe's mass but refuses to interact with light, to cosmic rays that bombard Earth with energy levels far beyond anything we can produce in labs, the cosmos is a treasure trove of mysteries waiting to be unraveled. Each discovery, or even the lack of one, pushes us closer to answering the big questions: what is the universe made of, and how does it all work? So, while the cosmic neutrino mystery remains unsolved, it's a reminder that the universe is full of surprises. Every time we think we've got it figured out, it throws us a curveball, and that's what makes exploring space so endlessly fascinating. As we've journeyed through the cosmos together, one thing has become abundantly clear: the universe is far stranger and more mysterious than we ever imagined. From the eerie signals of fast radio bursts to the baffling structures like the Hercules Corona Borealis Great Wall, every discovery seems to raise more questions than it answers. These cosmic oddities don't just challenge our understanding, they shatter it, forcing us to rethink what we thought we knew about the fabric of reality itself. Take, for instance, the enigma of dark matter and dark energy, which together make up over 95% of the universe yet remain invisible and undetectable by conventional means. Or consider the bizarre behavior of rogue planets wandering through the void without a star to call home, defying our expectations of how planetary systems form. And who could forget the hauntingly beautiful mystery of Tabby Star, whose erratic dimming patterns have sparked endless speculation? Could it be evidence of alien megastructures or something even more extraordinary? These mysteries remind us that the universe is a place of infinite wonder, where the rules we've come to accept are often bent, broken, or rewritten entirely. They're not just puzzles for scientists to solve, they're invitations for all of us to marvel at the vastness of the unknown and to embrace the thrill of discovery. But here's the thing: every answer we find seems to unlock a dozen new questions. And that's the beauty of science. It's a never-ending journey, a quest to peel back the layers of the cosmos and uncover its deepest secrets. So, as we wrap up this exploration, let's pause for a moment to reflect. What other secrets does the universe hold? What unimaginable wonders are waiting to be discovered in the farthest reaches of space? We'd love to hear your thoughts. What cosmic mystery fascinates you the most? Do you think we'll ever unravel the true nature of dark matter? Or could there be phenomena out there that defy explanation entirely? Share your ideas in the comments below, and don't forget to subscribe for more deep dives into the extraordinary mysteries of space. The universe is vast and the adventure is just beginning. Until next time, keep looking up, because out there among the stars, anything is possible.